This is going on page 90 when we're done. So we have our sine graph, we have our cosine graph, which we created with our fettuccine, right? And there's a reason I didn't just give you the graphs, then I had you do that. For kind of the same reason that we created the unit circle with those little triangles, because I wanted you to see that the unit circle is built off of the values from the special right triangles. That's where we get our special angle values from. And I wanted you to see when you were building that, that you were literally getting your values from the unit circle, even though we're thinking about the graphs differently. And that sine and cosine, same graph, it's just that cosine is sine shifted over to the left a little bit, right? Pi halves to be exact. So they're both sine waves, like we talked about yesterday, even though one is called cosine, and it goes on to say here, notice that the cosine function is a horizontal translation of the sine function. Any transformation of a sine function is called a sinusoid. Therefore, sine and cosine functions are called sinusoidal functions. It's a fancy way to say sine functions, sinusoidal functions. They are periodic functions because they repeat periodically, okay? All right, so speaking of the periods, one cycle, oh, missing there, can't see, hands in the way. There's one cycle of sine, here's one cycle of cosine. I don't have to start at 0. A lot of times starting at 0, especially with the parent function, just kind of makes more sense. But I could have started here and said, all right, well, one cycle ends here. That's still 2 pi units, either way you look at it. So you don't always have to start at 0. But this right here, this is a period. It's one cycle before it repeats. Same thing here. Oh, and then it does say functions that repeat at regular intervals are called periodic functions. I didn't realize it said that. So the actual definition of the period is the length of one cycle and it can start at any point on the graph. It's the length of one cycle, and it can start anywhere. Sometimes starting at 0 doesn't make the most sense, but if it does, we'll just start there. All right, so our amplitude. The actual definition of the amplitude that we'll write down is half the distance between the max and min points. So it's also the distance between the x-axis and a max or min of the parent function or from the midline, either way. But this right here is the amplitude. So is this. Okay, we can think of it as a few different ways, but I'm going to give you the actual definition of it. So it is half the distance between max and min values. Okay, frequency. Frequency and period are very much related to each other. The period is how long it takes to complete one cycle. The frequency is how many cycles do you get in 2 pi units in the parent function period. And they're used for different things. So this is how many, how do I say it? Oh yeah, just number of cycles in 2 pi units. So the sinusoidal waves, it's like sound waves. And if you've ever seen a sound wave, that's a sine wave of some sort. High frequency sound, the sound wave's going to look real crazy. It looks really crammed together, right? That's because it's high frequency. That means you get a lot of cycles in within 2 pi units. Okay, that's where all that comes from. It's all related to each other. All right, let's talk about the midline. So if we're going to shift, shifting the graph vertically will create a new horizontal axis called the midline. So for my parent function, the midline right here is at y equals 0. So this is f of x equals sine x. This is f of x equals sine x plus 4. It got shifted up 4 units. So this is my new horizontal axis, and that is at y equals 4. It's a reference line in which the graph oscillates. Okay, a word you may have had in physics already, but oscillating means it's going back and forth. The equation for the midline is y equals d, and it is an equation because it is a line. We good on all that? All right. So then down here we have the equations with the transformations again. It is missing c because for right now we're not going to put c in there. It's too much to do all at once. I tried to add something in here, but what I have to use to edit this, it was not happy with me trying to change these without doing weird stuff. So I just need you to add parentheses around the bx here because it's the cosine of that whole thing. So from here, we know that the amplitude is the absolute value of A, right? It's our vertical stretch and compression. The period, I don't get to pull directly off of the graph, off of the equation. It deals with B though, so it is 2 pi divided by the absolute value of B. The frequency is something that I can see in the equation. That is the absolute value of B. But if I needed to figure it out, the absolute value of B is equal to 2 pi divided by the period. Because remember, these are linked together, so to get one, it's 2 pi divided by the other one. Vertical shift is still your D, and then the midline, y equals D because it is a line. No sympathy for you if you're asked for the midline and you just give a number. It's a line. It has to be written as like an asymptote. Okay? We all get on all that? All right. So let's look at number 1 here. So we're given an equation, and we're going to identify these things. So we want the amplitude. Remember, amplitude is the absolute value of A. So what's the amplitude in this equation? 1, right? If it doesn't change, then it's the same as it was for the parent function. What is the frequency? It's the absolute value of B, which is 4, right? It's not 1/4. Yes, x does lie, but the frequency isn't your actual transformation. It just helps you with it, because then the period is equal to the absolute value, or 2 pi divided by the absolute value of B. So it's 2 pi over 4. What does that give me? Pi over 2. And then my midline is what? Y equals 2. Good. What questions you got? Okay. What is the amplitude in number 2? 7/2. What is the frequency? 1. So what is the period? 2 pi. Okay, because it's whatever it is with the parent function if it hasn't changed, right? And then my midline is y equals -3. Good. All right, number 3, what is my amplitude? 5, right? Because it is the absolute value of A. The negative is a reflection, but it doesn't affect the amplitude. What is my frequency here? 1/3, right? And remember, the frequency is the number of cycles that are completed in 2 pi units. So I only get 1/3 of a cycle in that 2 pi units, which means my graph got stretched horizontally, right? And we would know that this would be a horizontal stretch, right? Because x lies. Okay, so then I need the period. The period is 2 pi divided by 1/3. What is 2 pi divided by 1/3? 6 pi. That absolutely cannot stump you or slow you down. You have to know how to deal with fractions. Okay? And so it's 6 pi. It takes 6 pi units to complete one cycle. So that's another way you can look at it being really stretched. Then your midline is y equals what? 0. Because it's still a midline, it's just y equals 0. What questions you got? All right, you work on the next one. Okay, so those 3 are easy because you just pull those right off the equation, right? The other one is where some of you are going to go haywire because you want to make things difficult when they're not difficult. What is the period? 3 pi halves, yes. What questions you got? Anything? All righty. So then let's look at the graphs, kind of going the other way. We have the graph, and then we're going to come up with this stuff. Now, I've got to come up with these 4 things. I don't have to do them in this order. In my opinion, finding the amplitude first is not the easiest thing. To find, bless you, to find the amplitude, it would be very helpful if I knew where the midline was. So I'm going to find the midline, right? So I'm here, here's the bottom, and I go 1, 2, 3, 4 to get to the top. So that means halfway is 2, and I'm right here. So that tells me my midline is y equals what? 4. Because I'm at 4. It's the equation of the line. What is my amplitude then? 2. Okay? Because the amplitude is just right here. It's 2. All right. So then I'm going to look for one cycle. I've got one cycle right here. Depending on the graph you have, it might be easier to find the frequency first, or it might be easier to find the period first. The period is the length of this one cycle. Well, this doesn't end at a nice place, so I don't know about finding one cycle. I'd have to guess, and we're not allowed to guess. But I can complete 1, 2, 3 cycles in 2 pi units. Does that make sense? 3 cycles in 2 pi units, so my frequency is 3. Since my frequency is 3, what's the period? 2 pi divided by 3rd. Yeah, 2 pi thirds. Because that wasn't a fraction, so it was just easy to plop on there. Okay. What questions you got? All right, let's look at the next one. So let's see, I'm down here. I'll go 1, 2, 3, 4 again. So 2 to get to my midline. So my midline is at y equals what? -1. Amplitude is what? 2. From the midline to the top or the bottom is 2. Okay. When I look at one cycle here, well, sort of missed, but that's fine. What is the, can I get the period from just doing that? What's the period? 4 pi thirds, because it starts at 0, goes to 4 pi thirds. Totally works. Oh, I was about to write it in frequency. That is the period. 4 pi thirds. Frequency, I can do it mathematically. So let's say that I had to figure it out mathematically. I know that the frequency, which is the absolute value of b, that's equal to 2 pi divided by the period, which is 4 pi thirds, which I really didn't even have to write it like that. I could have written it as 2 pi times 3 over 4 pi. The pi's cancel out. That becomes 2, so I just get 3 over 2. I could also have gotten that from the graph, because here's one cycle, and then I only get half of another one before I get to 2 pi. So that's 1.5, which I would never write 1.5. I would write 3 halves, but I could get it either way. Okay. So you need to know how to do it mathematically in case the numbers don't work out nicely on the graph, but you can also do it graphically. Okay, we good? All right, so you do number 7. Okay, any questions about this one? Should get 4, 1, 2 pi, and y equals -2? Yes. The period is the length of one cycle. This is one cycle before it repeats. It starts at 0, goes to 2 pi. Okay? That makes sense? Okay. All right, then you do number 8. All right, do we all at least have the amplitude and the midline? Okay, so I want to talk about the period and the frequency and how you can look at it a couple of different ways. Because again, depending on what graph you have, you may have to do one or the other. So when I start here at 0, I only get half of a cycle in 2 pi. So my frequency is 1/2. Remember, I don't have to start at 0. You can start anywhere on the graph. So if I started here, then I can actually trace an entire cycle before it repeats. Does that make sense? And then that means, that tells me that I'm going from -2 pi to 2 pi, so the period is 4 pi, and that's why I only get half of one in the 2 pi units. Now it's fine to just find whatever and start at 0, and you can do the math and get there, but it's fine that it looks upside down. It's just one cycle before it repeats wherever you start, okay? What questions you got? All right, your assignment is in Delta Math. It is imperative that you practice this and do this before we start actually graphing tomorrow, okay? So your questions will ask you this. You'll have some graphs that ask you this, some equations that ask, it's very similar to what we just did on the notes. But practice that so you can solidify that in your brain before we start graphing.